So last class, what did we do? We started with the real applications, and what did that entail? What does that mean? What were we doing?
Inverse norm, right?
So we're doing norm CDF or inverse norm, right?
Yeah.
But we were doing them without having to what?
Without having to find the z-score, right?
Correct. So having to find the z-score would mean that we would put it in a standard normal distribution, right? So instead of using a standard normal distribution, we would go ahead and just plug it right in, right? We were going to do, so what were the commands? We were doing the norm CDF, and that would entail with the what? Lower limit, upper limit,
Median.
and then whatever the mean is, and then the actual standard. Instead of using 0 and 1, we would actually just go ahead and plug them in, right? So in other words, not having to find the z-scores, like Kyla said, okay? All right. So that's where we're at. Today we're only going to do the example number 4, and we'll call it a day. Example number 4, we are on page 248. Page 248. So we have significantly low or significantly high female pulse rate. So what does it mean when you hear that word significantly low or significantly high? What does that mean? We're going to work with 5% somehow, somewhere, right? It's going to be 5%, right? Because that's what we have defined when we started the entire class that we would call significant, right? Okay, so use the preceding criteria to identify pulse rates of women that are significantly low or significantly high. Okay, so when we did the pulse rates, we found that we had a mean of 74 with a standard deviation of 12.5. 12.5. So we need to find significantly low would be what? Would be on this end, correct?
Yes.
And this would be what? This here would be 5%, correct? Right? So we need to find this guy. So norm CDF?
No.
Why not? Why not?
Because there's have the area.
Exactly. So I know the area,
That's
right?
me.
I know the area, so we're going to do the we're going to do the inverse norm, and we're going to have the, what's the area?
0.05.
0.05, and we're going to do, what's the next thing? 74 and 12.5. Let's go ahead and run those numbers.
53.4.
What'd you get?
53.439.
53.439. So 53.439 would be the lower limit, right? What about the higher 5%? So I want 5% here, correct? What would that be? So I would go, what would I put here?
Same. No. Negative.
I don't think so.
0.95.
Yours will do, so the CE version, you can put the left tail or the right tail, right? For those of you who do not have that, what would you put? 0.95, exactly. You'll put 0.95, right? Because you would have 95% here, correct? All right, so we use 0.95. Right? There's one more way to do this. If I calculated the z-score here, can you see that this z-score is going to be the same as this z-score? One's going to be negative. This z-score is going to be negative, correct? And this would be positive, but they would be the same number because this is completely symmetrical, correct? You see that? Can you see that? Okay. So if I went like this, actually to find this, I would go 74 minus 53.439, and then I would add that to 74. Does that make sense? Because this is what? This is this distance here. So I go from here and I take that distance and I add it on the other direction. Wouldn't it be that end? Right? You see that? So let's go ahead and try the inverse norm 0.95 first. What do we get?
94.56.
So if I do the 0.95, I get what point of
94.561.
561. Subtract this for me. 74 minus this is going to be 20.561. Is that what we get?
Yeah.
You're going to add that to 74. Oh,
My goodness.
94.561. What a constant. Right? It works. Everybody see that? Everybody see that? Okay. All right. Okay. That's all we're going to do today. We are going to, well, I mean, that's all I'm going to do. You guys are going to do 13 through 25. So let's go ahead and pair up like we did before. Let's go ahead and pair up and do